Today we're going to take a look at arcs and chords. We're going to take a look at properties of arcs and chords of a circle. The first thing we're going to take a look at is the arc. For arcs and chords, the endpoints of a chord are also the endpoints of an arc. So what that means, if I look down here, I have chord AB. Notice its endpoints are A and B. I have chord DC. Their endpoints are DC, which means arc AB starts at A, ends at B. Arc DC starts at D, ends at C. Now there's a theorem that states, in a circle, two minor arcs are congruent if and only if their corresponding chords are congruent. So what that means is if AB and DC, if segment AB is congruent to segment DC, then the arc AB is congruent to the arc DC. This also works vice versa. If the arc AB and arc DC are congruent, so if DC and AB are congruent, then their chords are also congruent. So let's look at an example on how to use that theorem. The very first one, we're going to try and find a value for x. We notice here that we have some markings, MN and JK. These two chords are congruent, which means that their arcs are also congruent. Now if we notice, we do have the central angle coming in here. So if this arc and that arc are congruent, then these central angles are also going to be congruent. So we can solve this by setting these equal to each other. X plus 5 equals 50. And so when I solve for x, I'm going to subtract 5 on both sides. And x is going to equal 45. If I look over on this example, again, we see that this chord, AB, and this chord, DC. We need to find this value for x. We notice that we do have these central angles. If we look here, here's a central angle. Here's a central angle. They're coming through the center point. So that means that DE and AB, these arcs are going to be congruent because their central angles are the same. Since these are congruent, their chords are congruent, so x has to equal 7. So we're using some of the ideas from the last lesson and applying them here with this lesson. All right, let's take a look at the next things. Talking about inscribed and circumscribed. The chords of adjacent arcs can form a polygon. Quadrilateral ABC is an inscribed polygon because all of its vertices lie on the circle. And circle E is circumscribed about the polygon because it contains all the vertices of a polygon. So if we look over here at this example, we see that the vertices are these endpoints of this quadrilateral. We're all at A, B, C, and D. And when we connect all of these points, when we connect these endpoints, we see that we do form a polygon. In this case, some sort of a quadrilateral. And so this is inscribed about the circle, and the circle is circumscribed around or about that polygon. Okay? So we can kind of use that idea to think about finding some measures. We can find the measurement of each of the arcs of the circle circumscribed about a polygon. One thing to keep in mind, regular means that all sides of the polygon are equal. So if I look over here at this one, I'm given that I have a regular octagon. I have an octagon that is inscribed about the circle. And I want to find out what each and every arc is going to be. What is AB? What is BC? Well, since all of these chords, all of these sides are equal, so every single chord is congruent, that means every single arc is congruent. So if that's the case, I know it's 360 degrees around the circle. We're going to divide that by an octagon, which has 8 sides. And I'm going to find that I'm going to get 45 degrees is the measure of each arc. If I look here, I have an equilateral triangle. equilateral triangle, that means that all of these sides, again, are congruent. So all of these chords are congruent, which means if all the chords are equal in length, all of their arcs are equal in length. So again, I'm going to take 360, divide that by the 3 sides. I get 120 degrees. So AB equals 20. Arc AB is 120 degrees. BC is 120 degrees. CA is 120 degrees. All right. Another thing that we can do with another theorem we have is in a circle, if the diameter or radius is perpendicular to a chord, then it will bisect the chord and its arc. So looking at the diagram here, if I'm given that BA is perpendicular to TV, so BA is perpendicular to TV. Okay, we see the little 90 degrees, we know it's perpendicular. So what that means is that TV is congruent to UV. And I also know that this arc, TA, is congruent to this arc, AV. If I have a diameter or a radius that is perpendicular to a chord, then it bisects both the chord and the arc. So let's look at an example of what we can do to solve here. All right, so we are given circle W. The radius is 10 centimeters. The radius WL is perpendicular to the chord HK, and HK is 16 centimeters long. Okay, so what we're going to do with that is we're going to, we know a couple things right off the bat. If this is perpendicular, if WL is perpendicular to HK, that means that's going to bisect this piece. So if HK was 16 centimeters, that means that each of these pieces has to be 8. That's one thing that we get. We also know that our radius is 10 centimeters. So like say from W to M, that would be 10 centimeters. Okay? Which means the whole diameter would be 20. Well, let's start off with the first one. It says HL is 53. So I know that this arc is 53 degrees. This WL is perpendicular to HK, which means it bisects. So if I want to find out what is the measurement of, I have MK, but I don't have an M. I think this should be LK. If I want to find the measurement of LK, then I'm going to look here, and this bisects. So if HL is 53 degrees, then LK is 53 degrees as well. Okay, it bisects, so these two pieces are congruent. So this also has to be 53 degrees. If it asked me to find HK, okay, if I needed to find HK, then I could very simply add these two pieces together. 53 plus 53 gives me 106. Okay, now I want to find JL. I want to find this little piece right here. This is my unknown piece. Okay. But I'm not sure how. I know that this is 10, so X has to be 10 minus whatever this piece is. So that's where I'm going to start. I'm going to draw in a radius. So I'm going to draw in the radius WH. Now I know that this radius, it doesn't change, so that is still 10. So if I could figure out this piece here from WL, then I can find JL. So, okay, how can I do that? If you notice, I now have a right triangle. So I can go ahead and use Pythagorean theorem. So I would have 8 squared plus x squared equals 100 squared. So 64 plus x squared equals 100. I'm going to subtract 64 to both sides. I now have x squared equals 36. Take the square root, and I find that x is a value of 6. Now keep in mind that x is this piece right here. I really want to find JL. the whole from W to L, that's the radius, so that's 10, minus the piece that we found is 6, gives me a value of 4. So JL is equal to 4. All right, one last one to take a look at, and that is in a circle, two chords are congruent if and only if they are equidistant from the center. Okay? Now, one thing to keep in mind is that when we're finding something that is equidistant, we need to find its perpendicular distance. So if we look at this figure here, we have this chord FG, we have this chord JH. Here is my center point. I am finding the distance that's perpendicular from point L to FG, and I need to find also the segment that's perpendicular over here. If XL and LY are congruent, then the whole chord, and I know that I have these perpendiculars, then this whole chord FG and JH are congruent, and if the chords are congruent, then also the arcs are congruent. So we can get a lot of information here as long as we see that these chords are equidistant, then we know that the chords are congruent. Okay? So how can we use that to help us with some work? Well, looking at this problem here, it says the chords E, F, and GH are equidistant from the center. If the radius, so that means if these are equidistant, we know that we have right angles. We also know that these two are congruent. And so since we already know that, the radius of circle P is 15, and we know the length of EF is 24. We want to find what is the length of PR. So this is my unknown. Now I know if these are equidistant, then chord EF is also congruent to GH. So if this is 24 going across, then GH is 24 across. And note, just as we talked about in the last one, this is perpendicular to the chord, which means it's going to bisect it. That means that this piece here is 12, and this piece here is also 12. Now I need to find this side right here, just what is PR. Again, I'm going to draw in a radius, so I go from the center to a point on the edge. I know that the radius, it tells me the radius is 15, so that's 15. And again, I need to solve for x. So how am I going to do that? I'm going to use Pythagorean theorem again. I know that x squared plus 12 squared is going to equal 15 squared. So that means that x squared plus 144 equals 225. I'm going to subtract 144 from both sides, and I'm going to get that x squared is equal to 81. I'm going to take the square root of both sides, and so x is equal to 9. So that means the length of PR is equal to 9 units. All right, you have a worksheet to work on over problems very similar to the ones I did in the video. Have a wonderful day.